Today we're doing Fishkill Day 3. This one is applying the solubility rules that we learned of Day 2 to the White River itself. So the very top of it is just the answer key to the bottom of Day 2. This chart you will be able to use on your quiz. For this one today, we want to conduct an experiment to rule out aluminum, arsenate, and lead as possible river contaminants. So we're going to do a test to see if any precipitates form. Two tests. The first one, we're going to test some anions to see if aluminum and lead are present. And then we are going to test some cations. So for the first test, on Schoology, there are images. So on here, we'll see that chloride and sulfate both have no precipitates, but the sulfide, hydroxide, carbonate, and phosphate, all four of those do. So what we would do for those is we would fill out our chart saying, so no for chloride, PPT, 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 no, and then PPT. So what this means is these are insoluble, the ones with precipitate, and the ones without are soluble. We are then going to answer the questions below. So do the results of the river test match those of aluminum? So no with 3 precipitates, no, and a precipitate. So we're going to go back to the data from Day 2. We're going to look at aluminum. So aluminum and chloride is no. That one matches. Sulfide was precipitate. Hydroxide had precipitate. So did carbonate. So these 4 all match so far. Sulfate, this one had no precipitate, and then phosphate did. So the aluminum matches exactly. If we look at the lead, for chloride it matches. It matches for the sulfide, hydroxide. It matches for carbonate. But then it does not match for sulfate. So for lead, it said that sulfate, it should create a precipitate for. And in ours, it did not. So this one does not match for our lead. So do the results match those of the aluminum? Yes, they match the previous solubility and the river test. They matched identically. So could we rule out the presence of aluminum in the river water? So because it matches, we cannot rule out the presence of aluminum since the precipitates matched. Our data matched the presence. As for lead, so for lead, the results didn't match our previous data exactly. They were very close, but lead had precipitate for sulfate, while the river water sample did not. So that one did not match. So because they did not match exactly, we could rule it out. So because chloride was soluble, but the results showed otherwise for the sulfate, this means that lead is not present in our river water. Next, we looked at trying to identify if arsenate ions were present in our river water. So one that we didn't test, so aluminum will not be tested as aluminum forms a clear precipitate with arsenate, which is difficult to detect. So if we look at our Day 2 before we test, arsenate is on the far left-hand side. So it has no precipitate, it's soluble with our group 1. But everything else, all other cations besides group 1, seem to be insoluble. So let's look at our image from class. So silver, potassium, and iron, there are no solids in all 3. So since there are no solids forming, that means they are all soluble. So if they're supposed to be all soluble, that would mean no precipitate for all of them. Everything is soluble with the river test. Would that match arsenate? So think back how we did with lead, how we did with aluminum. If it matches, we can't rule it out. If it does not match, then we can rule it out, and then tell me in complete sentences why it does not match. As we continue down, so that is A and B. A is, do the results match that of arsenate? Yes or no, and why? Can you rule it out? Yes, I can rule it out. No, I can't. And why would that be? So look back at the lead and aluminum to see which one is similar to the arsenate and if we could rule it out or not. For 9, looking at the information below, can you rule out potential sources and explain your thinking? So we have a graph and it tells us some different locations of potential impacts. So here we have oil spill and farms are kind of along one. Think about location. Think about what it's made of or releasing here. So here is your farms and oil spill. 2, sewage treatment plant is right here in Anderson. The coal power plant. And then lastly, we have the aluminum smelting plant here is 4. So we've ruled out lead, but we have not ruled out aluminum. So if aluminum is a byproduct, then one of those could potentially be the causes. And remember, at the top here was the total fish kill. Here in the middle was a partial fish kill. And towards the bottom was a minimal fish kill zone. So use this map, write a paragraph here, 5 sentences or so, explaining your thought process, using some data from above and from the pieces here. Directly say which you can rule out as potential sources of pollution. There will be at least one that you can rule out as a potential source of pollution, if not a couple. Lastly, use the solubility rules from part 2 on page 1 to answer these questions. So can you form an insoluble compound with a sodium cation? Explain. So let's see. Go up to your chart. Sodium cation. Can we form anything that is insoluble? So since there is nothing listed as insoluble, no, we could not. All of the group 1 cations on the periodic table, so group 1, they're all going to give away an electron. Those will all be soluble with any anion, whether it's a nitrate, hydroxide, sulfate, phosphate, all of these negatives here, they're all anions. So those group 1 metals are soluble with any. So no, there are none that are insoluble. Giving 2 examples of chloride that would be insoluble in water. So same thing, go up to your chart again. Look at chloride. There are some that it is soluble with and some that it is insoluble. So which metals is chloride insoluble with? Those will make compounds. Which is it soluble with? So we want to list 2 that are insoluble. So everything should be complete sentences, but this one you can add a list. Just list 2 of them here for number 2 on the bottom. Then we have fill in the blanks with polar, nonpolar, or ionic. The rule like dissolves like means that polar, covalent, or ionic solutes will dissolve in blank covalent or blank solvents. Nonpolar solutes will dissolve in blank covalent solutes. So use these each 1 time if like dissolves like. For 4 here, plants need nitrogen to grow, but they can't use the nitrogen in the air directly. So there's nitrogen-fixing bacteria in the roots, and lightning strikes can convert that nitrogen in the air to ammonia, which is NH3. Also, synthetic fertilizers can contain ammonia. Plants can take in ammonia, but they rely on nitrifying bacteria to convert it first into nitrates. As a nitrate, nitrogen can finally be used by plants. So answer the question, complete sentences. Why is it important for plants that all ammonia, nitrate, and nitrite compounds are soluble in water? If they weren't soluble in water, think about how plants take in nutrients. Do plants eat things? Do they just like breathe it in? Why is it important that it is soluble in water? Then lastly, the shell of many marine organisms are made of calcium carbonate. Would you expect calcium carbonate to be a soluble or insoluble compound in water, and why? So why in particular for these shells? If it was soluble, what would happen to the shells? If it's insoluble, what does that mean for the shells? And then you can also watch the video and kind of see like impacts as to what, if it was soluble, would have to the seashells. So here, complete sentences, soluble or insoluble, and why would that matter to the marine organisms here if it was?